An advanced electronic project along with valuable tips. Today it's about the printed circuit and the casing. Developing electronic is a lot of fun, and here is a great example. While creating solutions for classic cars, we are sharing methods for electronic nerds. It's about a stepper drive that can be used in many different ways. So far, we created prototypes for water temperature, oil pressure, and fuel level. Additional instruments such as voltmeter and an ammeter are planned. Tests were showing that the concept is working exactly as expected. The pointer's direction, the type of measuring instrument, the deflection angle, and a lot more is configurable. The new stepper drives shall physically replace the old electromechanical pointer drives. There are several videos about it on the channel, where we are sharing our concept. Now it's getting exciting. We need to get the electronics into the small space housing the old instruments. So let's get started. First, we are creating the circuit diagram in KiCAD. Trying to keep the components numbering. Eventually, I realized that it is better to just let KiCAD do the numbering. Footprints for resistors, diodes, capacitors, voltage regulators, etc. can be found in the KiCAD library. We are choosing the vertical variant for most components to save space. The Arduino Nano version 3 footprint that I found was without labels, but adding these was no big deal. The X27 stepper motor footprint is not in the library, but no problem. Instead, I'm using 4 single contact connections, placing them on the PCB according to the technical drawing in the datasheet. 2 positioning holes instead of 1 are allowing alternative installation of the stepper motor rotated by 180 degrees. We need to populate the board at the front and back to accommodate all the parts. The green outlines are indicating the front parts, those on the back are magenta. Overlaps are possible as long as the parts are not hindering each other when soldering. We have to think carefully about the order of assembly. We are going back to the circuit diagram to give some helpful tips. It is essential to divide the circuit into parts that you want to place separate on the board. This is particularly important for the analog part to avoid interfering signals. We also want to separate the power supply and the rest of the circuit controlling the stepper motor, the LEDs and the buzzer represented as an LED here. An LED footprint is suitable for the purpose. You could even connect a third LED instead. We put the analog part on the board, including connection terminals, close to the analog inputs of the processor. In that stage, it is highly recommended to reduce conductor crossings by rotating components 90 or 180 degrees. The circuit diagram printed on paper is helping us a lot to keep track. We are applying the same procedure for the power supply and the rest of the circuit. 2 copper layers should be sufficient for our needs. We are connecting close parts using the front layer, here in light blue. Here is a tip. KiCAD is automatically placing conductor tracks close to the solder pads. You can move them to allow a second track run through, as here for example. There is no need for complicated routing around many solder pads. Instead, we are using the second copper layer here in green. If the labels are bothering us while routing, we can switch them off temporarily. The remaining connections are easy, thanks to our preparation procedure. Without preparation, things can get chaotic. I know that from my own experience. Yes, automatic routing would be nice. However, routing algorithms usually don't work very well, and they would be difficult to apply anyway, considering our conditions. There is little space left for the labels, but rearranging and reducing size makes them still readable. An additional labeling layer is sketching the stepper, the buzzer and our monster logo, which we obtained using the KiCAD image converter. Before sending the Gerber files to production, I'm double-checking the circuit diagram, the footprints assignment, the material list and the copper layers using KiCAD's test functions and Gerber viewer. Our trusted board manufacturer is PCBWay, the sponsor of this video. Ordering is very easy. Select size, quantity and number of layers, get price information, then you can upload your Gerber files. PCBWay is checking for completeness and errors. Inquiries about my special PCB casing design were clarified overnight. Take the easy way, with PCBWay. The KiCAD 3D viewer is giving us a preview of the assembled board. We are soldering these parts first, plus the cables of the buzzer, which are going in here. Next, these parts plus the Arduino are populated on the other side. Finally, we can solder the stepper and fix the buzzer at its place using some glue. Of course, the 7805 voltage regulator is bent over to fit into the casing. Here is the first casing design for a specific car model. The back panel can be changed, the depth can be varied using screws and spacers, as well as the position of the board. This opening is for wiring LEDs. You might want to put them on your dial. In case we are drawing more than 30 milliamps from our 5 volts output, the 7805 voltage regulator needs a heatsink. This window allows us to use the dial plate for this purpose. Here is a preview including plate, dial and a 3D printed pointer. It's one casing among other options. We will introduce more applications in later videos. Maybe we can realize your ideas. I'm looking forward to lots of comments. There's no tool creating a perfect PCB automatically, but you will achieve good results applying the tricks shown. Now we are looking forward to the implementation, and you will be the first to see it here on the channel. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.